November 5th, telescopes across the world turned toward the expected position of 3I Atlas. They were looking for a faint dot, magnitude 15. What they found was blazing at magnitude 10, 100 times brighter. Something had happened behind the sun. Welcome back. For those who've been following 3I Atlas since its discovery in July, the third confirmed interstellar visitor to our solar system, the last 2 weeks have been extraordinary. Let me get you up to speed quickly. On July 1st, astronomers discovered this object. Its trajectory immediately stood out. It didn't orbit the sun like objects born here. It came from interstellar space, more than 7 billion years old, older than our sun, carrying secrets from an ancient star system we may never identify. Late October, it swung around the sun at just 11 million miles. Then it vanished into the solar glare for weeks. And during that time, something remarkable happened. November 5th. Observatories worldwide pointed their instruments at the coordinates where 3I Atlas should reappear. They expected a faint speck, magnitude 15, maybe 14 if they were lucky. What appeared was magnitude 10. Now, some of you are already doing the math. That's not just twice as bright, or 10 times. Magnitude 10 versus magnitude 15, that's 100 times brighter than predicted, and that shouldn't be possible. Let me put this in perspective. Imagine you're expecting to see a 60-watt light bulb at the end of a football field. Instead, you're hit with the glare of a car's high beams. That's the scale of difference we're talking about. Comets brighten when they approach the sun. We know this. The heat vaporizes ice, creates a coma, forms tails. Basic comet behavior. But this was different. Oumuamua, the first interstellar visitor, never showed this kind of outburst. Comet Borisov, the second, behaved like a regular comet from our own solar system. 3I Atlas is playing by different rules. The James Webb Space Telescope data from August already showed something unusual, a dense envelope of carbon dioxide, signs of massive outgassing. But this level of brightening? The models didn't predict it, couldn't predict it. 3 theories are circulating among astronomers. First, massive chunks of ice broke off the surface and vaporized suddenly. Second, cascade effects inside the nucleus triggered runaway sublimation. Third, we're witnessing something we've never seen before.
Which would you bet on?
But while astronomers were puzzling over the brightness, the European Space Agency was quietly achieving something that could one day save millions of lives. ESA's ExoMars Trace Gas Orbiter, circling Mars, locked onto 3I Atlas as it emerged from solar conjunction. What they accomplished sounds technical, but here's why it matters. They measured the comet's trajectory 10 times more precisely than ever before. 10 times! Think about what that means for planetary defense. An asteroid is heading toward Earth. We launch a deflection mission, but if we don't know the exact trajectory, if our calculations are off by even a fraction, we miss. Billions of dollars, years of preparation, gone. And the asteroid keeps coming. The technique ESA tested on 3I Atlas works, and it works on objects that barely reflect light. Just like most dangerous asteroids, 3I Atlas will never hit Earth, but the methods we're developing on it, those could stop an asteroid that would. Here's the irony. This ancient visitor from another star system might teach us how to protect our own planet. And speaking of tomorrow morning, November 19th, NASA will show us something we've never seen before, an interstellar comet in unprecedented detail. The Mars Reconnaissance Orbiter has been circling Mars since 2006. Its high-rise camera is so powerful it can spot objects the size of a kitchen table on the Martian surface from orbit. And it photographed 3I Atlas. These aren't Hubble images from 93 million miles away. These are close-range observations from a spacecraft that was perfectly positioned. The resolution? Significantly better than anything Hubble captured in July. What are scientists hoping to see? Structures in the coma, evidence of fragmentation in the nucleus, details about the tail formation and outgassing patterns. These images could solve the brightness mystery. They might show whether 3I Atlas is breaking apart, like Comet Atlas C2025 K1 did just last week after its own solar encounter. Different comet, confusing name, I know. Or they could show something entirely unexpected. Think about this. We've only had 3 interstellar visitors, 3 data points. Oumuamua showed us a rocky, cigar-shaped tumbler. Borisov showed us a normal-looking comet. Now 3I Atlas is showing us outbursts, extreme brightening, behavior that doesn't match our models. Each visitor reveals how little we actually know about what's out there. Even if NASA's images tomorrow provide answers, the story of 3I Atlas isn't over. In fact, it's about to get even more interesting. Late November, ESA's JWST spacecraft, Jupiter Icy Moons Explorer, gets its turn. It'll conduct additional measurements as 3I Atlas moves outward through the solar system. Then, the comet leaves. It retreats into deep space, growing fainter each week, harder to observe. But here's the fascinating part. We can now trace its path backward. The precise ESA trajectory data allows us to reconstruct where it came from, and the models suggest something remarkable. 3I Atlas may originate from a region near the galactic center, an area populated by ancient stars born more than 10 billion years ago. This comet is a time traveler. It carries information about conditions that existed when the universe was young, when our galaxy was still forming, before our solar system existed. The carbon dioxide envelope Webb detected, that could tell us about the chemistry around those ancient stars. The outgassing patterns, they reveal how ices behave after billions of years of cosmic ray bombardment. Every observation adds a piece to the puzzle. Here's what I want to know from you. Do you think NASA's images tomorrow will solve the brightness mystery, or will they raise new questions? And here's the bigger question that keeps astronomers up at night. How many interstellar objects pass through our solar system without us noticing them? Leave your thoughts in the comments. The next 24 hours will be revealing. NASA promises the most detailed images of an interstellar object we've ever seen. What they show us could explain the 100-fold brightness increase, or it could show us something we've never witnessed before. Either way, 3I Atlas has already taught us something valuable. The universe is far stranger than our models predict, and every visitor from beyond our solar system rewrites the rulebook. Until next time, stay curious.